Action. Hey Science Seekers, this is Mr. Pfeiffer. I'm here with Erica, Alana, and John. They are here to help us do a demonstration, a very popular demonstration called elephant toothpaste. So to do this demonstration, we're going to need some substances. Alana, can you tell me what is in this container right here?
This is H2O, also known as water.
All right. And what is this substance? Don't touch it.
This is hydrogen peroxide, also known as H2O2, which has one extra atom in it.
One extra atom of oxygen. Okay. So what I'm going to do now is hand this over to John so he can hold on to that camera while I do some demonstrations. We're going to pour these into the graduated cylinders. Here's our water, and here's our hydrogen peroxide. Now, Erica, what do we notice about the properties of these substances?
They look almost identical, but they're both odorless and colorless.
Yeah, so these are almost the exact same physical properties of being colorless and odorless. Now, John, I'm going to go ahead and pour in the water some soap, okay, which is important for elephant toothpaste. We need that to help make the big foam reaction that we're going to see. Now, this is the water. And where do we notice? If you want to zoom in on the water, what's happening to the soap in the water there, John?
It's mixing.
And it's going down to the
Bottom.
All right. And then, John, what's going on, buddy, with the hydrogen peroxide?
Since it's more dense than water, the soap is staying on top.
So we can see this is a different property, all right? The soap is floating on top because it is not as dense as hydrogen peroxide. And that makes sense because hydrogen peroxide is H2O2. All right. So the next thing we're going to need, John, if you can please grab that hammer for a minute, is we're going to take our hydrogen peroxide and step away from the water because the next step is to put this in a bigger graduated cylinder. Now what I have here is called a catalyst. This is known as sodium iodide. When you add a little bit of this to soap and water, okay, it doesn't really do anything. It just makes soapy, bubbly water, right? But the thing is, when you add this to a substance like hydrogen peroxide, it starts an oxidation process that basically has the hydrogen peroxide combined with the soapy bubbles. The oxygens start breaking apart and you get some fearsome bubbles. So here we go. In 3, 2, 1. A quick oxidation. We actually have a little bit of rust forming, which is that little orangish color. And as we can see, the bubbles are rising. They're moving up. A way different chemical reaction than water. H2O2 clearly is different than water. And in the end of the day, you even have what we call a exothermic reaction. We're going to see not only an explosion of soap, we are also going to see heat and steam rising and coming off of this graduated cylinder. You can see it right here in the center. As John's zooming in on the steam. That's what we call exothermic, as heat is being released from this chemical reaction. This is a great example of a chemical change in a chemical reaction, also known as elephant toothpaste. Peace out, guys.